Hey everyone, welcome to the Chapter 2, Section 1, Part 1, Solving Systems of Equations with Substitution. I'm doing this with 2 variables. If you'd like to see them with 3 variables, that'll be in Parts 2 and 3. So, I have 5 examples here. I'm going to try and do them as quickly as possible. Hopefully get this video under 15 minutes. So, let's get started. When you're solving with substitution, you want to be able to, you have at least 2 equations, and you want to be able to solve one of those equations for a variable, meaning you isolate it, you get it equal to that variable. So like this first equation is equal to x, because it literally says equals to x, so it's solved for x. So what I'm going to do is I'm going to take this, and then y plus 3 is equal to x. So it's like changing out a dollar bill with 4 quarters. A dollar bill can represent my x, and y plus 3 will equal my 4 quarters. They're equivalent, they have the equivalent value, just different in appearance. So I'm going to replace the x, or substitute the x in the other equation with the y plus 3. So I'm going to remove the x, well I should be saying substitute the x with y plus 3. So I'm going to write down the other equation of y plus, and then I'm plugging in y plus 3, and then I'm just bringing the rest down from that other equation. So the whole reason why you do this is because you can solve a variable, you can solve a one variable equation quite easily. Now if you have 2 variables in one equation, you can't exactly solve that. You can't get an answer like y equals 3 or something like that. So by doing this, we now have the same variable twice, and we only have one variable, just one letter, a y. So I can combine like terms here and say 2y plus 3 equals negative 1. This is an equation I can solve. I can get a specific numeric answer for y. And then I can get that y value and plug it in and figure out the x value. So it'll go like this. I can minus 3 over to the other side. And I get 2y equals negative 1 minus 3 is negative 4. And so split up a number and a letter by dividing them. They are married multiplying together, 2 times y. So I got to divide them away from each other. So I'm going to do y equals negative 4 divided by 2. That's going to be negative 2. So I just figured out what y equals. But I had an x and a y variable in my 2 equations. So I'm going to take the negative 2 and I'm going to plug it in for y right there. The reason why I'm going to do that is because x equals y plus 3, right? So if I just plug in that y value, I'll know what x equals, because I have an equation that's already in x equals form. So I have x equals, y was negative 2 plus 3. So what's negative 2 plus 3? That's the same thing as 3 minus 2. That's 1. So x equals 1. Or there, I'll write it like that. And then what you want to do is you want to write them as an ordered pair for your final answer, because these are 2 linear equations, okay? And all linear equations can be graphed, and if you were to graph these 2 lines, they would intersect at 1 comma negative 2. See, so what I did was I went over to the Desmos app and I graphed this, and I didn't even do any work. I just typed in the original equations and it showed me the intersections at 1, negative 2. You can always check your work that way. But let's move on to the other examples. Here I have 2 equations. Neither one of them is solved for x or solved for y. So what you need to do is you need to make a judgment call. Which equation will be easier to work with and which variable looks like it'll be easier to solve for. And so for me, I look at this top equation and I see that all I have to do is add 2y over to the other side and it'll be solved for x. So that's exactly what I'm going to do. I'm just going to add 2y over to the other side. And now I have x equals 2y. I like to put the letter first. So if I add a positive 2y, I have 2y, and I have a positive 8 plus 8. And I'll take that, and then I'll plug that in for x into the other equation. Okay? So I now have 2, and then parentheses 2y plus 8, and then bring down everything else. So plus 3y equals 2. Now, anytime you have a number or something on the outside of your parentheses, you're going to have to distribute. So multiply everything on the inside of the parentheses by 2. The most common mistake I see people make is they distribute the 2, but they also distribute like this. They multiply 3y times 2 and this 2 times 2. Only what's inside the parentheses, that's all you need to distribute. So 2 times 2y is 4y, 2 times 8 is 16. Bring down the rest, plus 3y equals 2. And so now I see I have 2 y terms I can combine. That'll make 7y plus 16 equals 2. Alright, so I'm solving this equation for y. So I need to minus 16 to the other side. You know, a real common mistake people make is they add things together when they're not like terms. And so they have 7y plus 16, and then they'll say that equals 23y. Alright, if it doesn't have a letter with it, you can't combine it to make one singular number. You need to add or subtract that over to the other side. And so I get negative 14 here, because it doesn't have a y with it. If it has y's with it, like I did here, you can combine them. But if it doesn't have a y with it, then you need to get it to the other side because it's not going to combine. So divide everything by 7, because you have 7y, that means 7 times y. So the opposite of that would be divide by 7. And negative 14 over 7 is negative 2. So y equals negative 2. Plug it into your x equals equation. So x equals 2y plus 8. So instead of y, put a negative 2. What's 2 times negative 2? That's negative 4 plus 8. That'll make positive 4. Alright, so my final answer will be 4, comma, negative 2. And that's it for example 2. Example 3, you know, neither one equation's already solved for x or y. So I'm just going to pick the top one. I see that they're all divisible by 3, 6, 15. So I'm going to solve this one for y. So I'm going to add 6x over to the other side. And again, I won't combine it with the 15. It stays separate because it doesn't have an x with it. So 6x plus 15 or 15 plus 6x, doesn't really matter, but I prefer to write the number term first. And then divide everything by 3. Remember, a number and a letter are married together because they're multiplying, so divide them apart. So 6 over 3 is 2, y equals 2x, 15 over 3 is 5, plus 5. You now have a y equals statement. Plug it in for y into the other equation. So negative 2y plus 2. So except it's going to say negative 2, parentheses, 2x plus 5 plus 2 equals 4x. Now I got to distribute negative 2 times 2x and negative 2 times 5. That'll make negative 4x minus 10 plus 2 equals 4x. So I have negative 10 plus 2. That easily combines to make negative 8. And so I have negative 4x minus 8 equals 4x. So I need to get my x's on one side. It wouldn't make sense to move this over because then I'd have everything on one side. So I'm going to move this negative 4x over to the other side. So opposite side, opposite operation, plus it over. And I get negative 8 equals 8x. Divide everything by positive 8. Negative 8 divided by positive 8 is negative 1. So if x equals negative 1, we need to figure out what y equals. We know that y equals 2x plus 5. So y equals 2, parentheses, negative 1. Replace the x with the negative 1, plus 5. This will make negative 2. 5 minus 2 is 3, so y equals 3. So final answer, negative 1, comma 3. And that's it for example 3. Example 4, looking at this, it doesn't really seem like either one will be difficult to work with. So I am going to just add 3x over on this one and solve it for y. Why did I choose this? If I do this, I have less to write down. I don't have to copy down the equation again. So 3y equals, I like to put the number first, or the letter first, sorry. 3x plus 12. Okay, split up the number and the letter by dividing. And so if something's canceling from division, it technically makes 1. You have 1y equals 1x, like you have 1's in front. But you don't really have to write the 1's now, do you? Just thought I'd bring that up. So y equals x plus 4, or 1x plus 4, however you want to write it. Take the x plus 4, plug it in for y into the other equation, so that one right there. So replace the y with x plus 4, so I get negative 4 parentheses x plus 4 minus 2x equals negative 4. And see what I mean? When you plug it in, I said this after the first example, during the first one, you should be replacing a letter, so you now have the same letter appearing twice. It's an easy mistake to make. You accidentally plug it into the wrong letter. So if you see like a y here and an x there, you're like, oops, I messed up. Just erase and go back and plug it into the other letter, because you're supposed to see the same letter twice. Otherwise, you're not helping yourself if you have two different letters again. So distribute the negative 4. Negative 4x minus 16, bring the rest down. Minus 2x equals negative 4. I see I have two like terms I can combine. I can combine negative 4x and negative 2x for negative 6x. Minus 16 equals negative 4. Alright, so now I can solve for x. I know I can plus 16 to the other side. I wouldn't combine it with the negative 6 because it doesn't have an x with it. And so I have negative 6x equals positive 12. How do I get rid of a negative number by a letter? Same thing for any type of number, just divide it out. So 12 divided by negative 6 is negative 2. Now that you know x is negative 2, figure out what y equals. We have y equals x plus 4. So y equals negative 2 plus 4. So that's 4 minus 2, that's positive 2. So y equals 2. So rewrite your final answer as negative 2, comma 2. All right, and that's it for example 4. I got one more example to do. All right, so if I look at this top one and I try and solve it for x, I'm going to have to divide everything by 3, and then I'll get fractions. If I solve it for y, I'll have to divide everything by 7. I'll get more fractions. So that means I want to work with the second equation. If I divide everything by 5, 10 is divisible by 5, 65 is divisible by 5. You know something's divisible by 5 if it ends in a 5 or a 0. So I'm going to work with the bottom equation, and then I'm going to solve it for x because it has the 5 with it. So that means I'm going to minus the 10y over. So for those of you watching this and wondering, how does he decide which equation or which letter to solve for? That's how. You just kind of ask yourself those questions. What looks like it'll be easier, and then think about what number am I going to have to divide things by. So minus 10y over to the other side, and then divide everything by negative 5, and you'll have your equation or your statement for x. X equals, that'll make positive 2y, this will make minus 13. Plug that into the equation we haven't touched yet, which is the top equation. I'm going to replace x with 2y minus 13, so 3 parentheses 2y minus 13 plus 7y equals 26. I now have the letter y appearing twice, which is good. We'll get an answer for y that way. Distribute, that'll make 6y minus 39 plus 7y equals 26. Combine like terms, you get 13y minus 39 equals 26. And then that 39 is not a like term with the 13y. It doesn't have a letter with it. So plus it over, and that'll make 65. 13y equals 65. So 13 is multiplied, married to y, so divorce, divide it by 13. And then you get y equals 5. So if y equals 5, what does x equal? Plug it in. X equals 2 parentheses 5 minus 13. 2 times 5 is 10. 10 minus 13 is negative 3. And so I get my final answer written as an ordered pair as negative 3, comma 5. So that'll wrap it up for part 1 of this video. Stay tuned for additional videos on this topic. Thank you for watching. Hit that like button, hit that subscribe button, if you feel like it. Bye-bye.